Hello, this is Scott with Second and No One Canine Life Coaching, and I'm reading from The Arcology of Mind by Jock Panskep and Lucy Bivens. Give you a little bit of a. That's the book. Lucy Bivens, excuse me, not Bivens. Forward by Daniel J. Siegel. You might recognize him as some of the other stuff, the hand-brain model. Brainstem is your forearm, the amygdala, hippocampus, and then your prefrontal cortex in the upper brain. If you go to freak out, it's because of this. You gotta flip your lid. That's Daniel J. Siegel and Lucy Bivens. So I'm going to talk about the seeking system. 2 generations and counting of misunderstandings about the seeking system. Already related, the seeking system was first introduced in 1953 by Olds and Milner at McGill University in Canada, although they did not call it the system by that name. This is on page 116, by the way. While looking for other things, i.e. how artificially induced brain arousal tension might facilitate learning, they stumbled upon the phenomenon that animals could work in order to receive tiny electrical jolts to specific parts of the brain. At times, Jim Olds, 1922 to 1976, called this the pleasure system. But other investigators were rather more prudish, at least until the 1980s, when the grand exploratory era of self-stimulation research had come to an end, and most investigators started to focus on the dopamine component of this complex system. From then on, practically everyone was calling it the brain reward, or even reinforcement system. Reinforcement. But one must suspect by the time that he was writing his last book, Olds, 1977, Olds had realized that there was much more to the system than the creation of pleasure. He had started to study the classical conditioning of appetitive drives by pairing a tone with delivery of food to hungry rats and monitoring the neuronal activities throughout the brain. He discovered that many places in the brain learn to anticipate the forthcoming food. I see you. He discovered that many places in the brain learn to anticipate the forthcoming food. But the fastest neuronal conditioning and the earliest signals of indicating that the animal was anticipating the food were coming from neurons along the MFB-LH corridor that we were calling the seeking system. The firing of cells typically predicted the forthcoming reward, but Olds never seemed to make up his mind that they were actually discovered was the brain system that eagerly anticipates rewards rather than just registering the pleasure from consuming the rewards. There's a difference, anticipatory and consuming, than just registering the pleasure from consuming the rewards. A few years ago, Olds' untimely passing, Panskep had discussed the expectancy/seeking hypothesis with him on a flight to Europe. Oh, how cool. Then he had been intrigued, noting that now his electrical physiology work was consistent with that idea. So it's great when minds get to go together that aren't exactly in the same field, but they're actually hanging out together. And the one part I want to discuss was these rats were actually had electrodes in their brain, and they could turn them on. They could turn on the electrical stimulation when they found something they liked. That's pretty interesting. That's asking and seeking if they like something through electrical stimulation. The discovery of brain rewards by Olds and Milner was surely one of the greatest neuroscientific discoveries of the 20th century, back in 1953, around 53-70s of the 20th century, leading eventually to studies that have revealed the neural underpinnings of learning and addiction. Learning. That's all I'm all about that. Animals would learn all kinds of things with the MFB-LH stimulation. That's a whole corridor in the brain. From pressing levers to running down particular paths in a maze, which are formally called operant and instrumental conditioning. We don't hear about instrumental conditioning, do we? They call the effect self-stimulation because the animals played an active role. They worked in order to receive electrical jolts of joy. One might even suggest they discovered a form of mental masturbation. Animals tickled their brain regions that were evolutionarily designed for getting other goodies. After all, what a person masturbating really wants is an erotic relationship, but for various reasons ends up taking care of his or her satisfactions alone, closely resembling an addiction. Zellner estimated AL 2011. Funny now they're going to talk about that, huh? And now we know that this general purpose seeking system is critically important for all kinds of addictions, from drugs such as cocaine and morphine to dependence on alcohol and nicotine and even sex. Wise and Romper, 1989. Robinson and Barrage, 1993. 93. They're talking about this addictions in 93. 93 was not that long ago. And this is how we're actually changing how addictions are seen and mental health is seen. The system is also the force behind all kinds of creative activities. Reuter, 2005. One big problem remains. Most young investigators who have inherited the study of this fascinating brain system, remember the reward system, not the seeking system, but that's what they call the reward system, hardly question the unitary concepts such as reward, quote, reward, unquote, and reinforcement, quote, reinforcement, unquote, reinforcement, that were handed down to them by previous generations, as if they were unitary phenomena. Indeed, the concept of, quote, reinforcement, unquote, may have just be a summary term for ignorance, perhaps the, I don't know this one, phlogiston, STON, excuse me, phlogiston of behavioral science. And there's a little 2 right there, so I have to read that at the end too. That was simply convenient procedure for training animals. However, as a brain process, this did little more than cover and hide a mountain of ignorance. Along the way, most investigators of this brain reward system have failed to consider the actual natural behavior patterns, characteristic exploratory activities, and the animal's spontaneous exhibit when the seeking system is artificially aroused. Animals will self-stimulate many areas of the brain. The main one are the septum and the LH, through which the course of the MFB that contains the ascending dopamine systems, but also many other neural networks. We already know that self-stimulation of the MFHLB and other septal areas are experienced quite differently by animals, although sites along the MFB-LH tend to feel the same to animals since they have difficulty discriminating 2 distant sites along this pathway. This is them in the brain stimulating it themselves for rewards. Or is it reinforcement? So Stratz ETAL 1974. Because very little discriminating work like that has been done, we must assume that many other brain sites that mediate self-stimulation also generate distinct types of rewards. In any case, the brain contains many reward systems. Now, there have been several generations of scientific passing of the buck about the kind of reward that is engendered by the MFH-LB stimulation. But we probably don't have to repeat that the global concept of the brain reward system is rather off the mark, even though people who know better continue to use the term. Haber and Knutson, 2010. This is all pretty new books and research that's still going on. This description simply does not capture the natural behavior patterns that is such brain stimulation evokes in animals, and the electrophysiology consistently indicates the system is designed to first get excited about newly found rewards, then rapidly comes to anticipate them. If more is coming, then rapidly comes to anticipate them if more is coming. The bottom line is that animals getting MFH-LB rewards simply do not behave as if they are consuming a delightful treat and experiencing a sensory affective reward. Stimulation of the septal region produces behavior that is closer to that. When animals self-stimulate the LH, they do so in a frantic way. They frantically press levers with nose sniffing a mile a minute, almost as if they are trying to see what is behind the lever to explore it. And they typically work harder than necessary to get all the rewarding electrical jolts. In contrast, animals self-stimulate the septal area with very different behavioral attitude. They work with a methodical pace, usually pressing the lever once for each shock and without agitation. By various measures, it does not appear that stimulation of the septum is any less pleasurable than LH stimulation. And by human self-reports, septal stimulation actually does evoke feelings of pleasure. Heath, 1996. Remember, we're only in 2019. 96. I was 18. Graduating high school. No, I lied. Yeah, I was supposed to graduate high school then. Why then do animals work so excessively hard to obtain the LH stimulation? The most... By various measures, it does not appear that stimulation of the septum is any less pleasurable than LH stimulation. And by human self-reports, septal stimulation actually does evoke feelings of pleasure. Heath, 1996. When animals do work so excessively hard to obtain... Why then do animals work so excessively hard to obtain LH stimulation? The most reasonable hypothesis is that the seeking system induces a robust mental and behavioral invigoration. The kind of arousal animals display before they get forthcoming rewards as they experience some kind of euphoric enthusiasm. Just think of a hungry dog bounding up and down, sometimes in a circle, as you bring them a bowl of food. However, in the early days following the discovery of self-stimulation, behavioral concept ruled that the only meaningful scientific way to discuss animal behaviors. Even ethologists who prefer to study the natural behaviors of animals in the wild constrain their analysis to accurate descriptions of behavior with no hint of any mental constructs, and emotional issues were rarely discussed. The Nobel Prize-winning ethologist Nico Tinbergen noted that since, quote, subjective phenomenon cannot be observed objectively in animals, it is idle to claim or deny existence, unquote, 1951. There was a taboo against any talk of the subjective aspects of the brain, Wallace, 2000. Thus, it is no surprise that the animal mind was largely neglected by scientists, at least until Donald Griffin, 1984, 2001, started to talk forcefully about the possibility of animal consciousness again, an exercise that was quite popular, perhaps too in vogue, during the late 19th century. Lindsay, 1880, especially by Darwin's protege, George Romanes, 1882. So we did try to discuss emotions back with Darwin, remember? And then all of a sudden, we discovered, not going there. When Olds and Milner discovered the phenomenon of self-stimulation, behaviorism was at its zenith. The biggest achievement of the behavioral movement was its discovery that animals can be coaxed to work in specific ways. They will display an operant instrumental behaviors in highly predictable patterns when rewards, usually in the form of food or drink, are delivered at particular times, according to various reward delivery procedures called schedules of reinforcement. For instance, under one schedule, when food is delivered after a fixed number of responses, fixed rate schedules, sort of like chopping wood, animals press the lever fast as they can, eat the reward, relax for a little bit before beginning another flurry of maximally fast operant behaviors. They work somewhat more slowly but at a steady pace when rewards are delivered unpredictably. After varied numbers of operant lever presses, variable ratio schedules. Almost done. When rewards are delivered at irregular intervals of time, regardless of the number of operant behaviors, fixed interval schedules, animals press levers slowly after receiving a reward and press increasingly quickly as the time approaches when the reward is about to be delivered again. It looks like a curve of increasing anticipation. Animals work comparatively slowly, but rather steadily if rewards are delivered at various unpredictable times, regardless of how often the animal presses the lever. It is hard to visualize these verbal descriptions, but there's actually a chapter on that, or a graph. That is some interesting stuff. What do you guys think about that? Under one schedule, when food is delivered after a fixed number of responses, animals press the lever as fast as they can, eat the reward, relax for a little bit, before beginning another flurry of maximally fast operant behaviors. They work somewhat more slowly, but at a steady pace when rewards are delivered unpredictably. So if they know it's coming, or they don't know it's coming, they don't work as hard. If they know it's coming, they work even harder. Now what happens if we up the ante with the rewards? The type of rewards, the motivators, what kind of mood are they in? That's all for now. This is Scott with Second and No One, Canine Life Coaching. Have a great day. That's not even a full chapter of the seeking system. That's a section of the seeking system. The next one is schedules of reinforcement and the brain effects of brain reward.